Welcome Math 20-2 to Lesson 5 where we're going to learn about scale diagrams, okay? So let's start off here with this first example. It says, the lengths of sharks are generally measured from the tip of the nose to the middle of the tail, okay? So measure the length of the shark in the scale diagram and use proportional reasoning to determine the actual length of the shark. So here we go, here's my shark. And we read this, it says 1 centimeter is equal to 0.5 meters. So I'm going to measure him, go like this, and I end up getting around, from the tip of the nose to the tail, to the center of the tail, I get around 9.6. Okay? So we have 9.6. So we have 1 centimeter is, I'm going to push this up here, is equivalent to 0.5 meters. Alright? Now, I look at this, I actually have 9.6 centimeters. So I look at it this way, I am multiplying this by 9.6, so I'm going to have to multiply this here by 9.6. And when I end up doing that, I end up getting 4.8 meters. So what is my total? My shark is 4.8 meters long. Okay, there's a decimal there. All right? Now, let's take a look at this next one here. We're looking at the Alberta map. Okay? Just move this a bit so you can see everything. So, it here says, use the line graph scale to determine the approximate distance between Calgary and Edmonton. So if I look at my line graph scale right here, I have this much here is 75 kilometers. So let's measure and see how much that is. So we have every centimeter is approximately 75 kilometers. So we want to go from Edmonton all the way down to Calgary. So let's measure that here. I am going to get just approximately 4 centimeters, just under 4 centimeters. Okay? So I have, let's see, let's measure that again. Oh, Edmonton's there. I was going from St. Albert. Edmonton all the way to Calgary, which is right around there. I get, 3.7 I get. So I'm going to say 3.7. So it's 3.7 centimeters. Okay, and I know 1 centimeter is equal to, just move this here so we could see my question. So 1 centimeter is equal to, we said, 75 kilometers. Okay, and we have 3 centimeters, 3.7 centimeters would have to be equal to what then? I multiply both of these by 3.7, is how I got that, so I have to multiply this by 3.7. Okay, so if I grab my trusty calculator, I go 75 multiplied by 3.7. See here, we go 75 multiplied by 3.7. I'm going to end up getting 277.5 kilometers. So it is 277.5 kilometers from Edmonton to Calgary. So basically what we do is, once again, we measure from Edmonton to Calgary, and then we look at our scale. So that was 3.7 kilometers. Then I look at my scale. Each centimeter, we look at that, is equal to 75 kilometers. So 3.7 centimeters, and we just measure. So let's try another one here. All right, there we go. So for this next one here, let's take a look at my question. We have the map of British Columbia. It says, calculate the approximate straight line distance between New Hazelton and Prince George. So we have to find New Hazelton and Prince George in this map. So here's New Hazelton. Prince George is here. So let's see how far that is. That is a total of, I get 3.5, I think. Oh, maybe a bit more. Yeah, I say it's around 3.5. So I get this is 3.5 centimeters. Okay? Now, I look at it. I'm going to do this one in a slightly different situation. So move this up. We have, right here, 1 centimeter is 100 kilometers. So I'm going to go 1 over 100 is equal to, because this is centimeter per kilometer, is equal to 3.5 centimeters over x. Okay, so I'm doing this way now. And now to solve this, we're going to cross multiply. This goes there, this goes there. Okay, so I'm going to end up getting x is equal to 3.5 multiplied by 100. And I look at that, I'm going to get 350 kilometers. Okay? Because then we have to move these, because it's all divided by 1 centimeter, so the centimeters cancel off. So I have 350 kilometers. Okay? Now, here it says, is the answer in A a realistic estimate of the actual driving distance between New Hazelton and Prince George? Okay, and I'll describe the method of a more accurate driving distance from New Hazelton to Prince George. Well, I take a look at this. Let's take a look at the map. If we look at New Hazelton to Prince George, it winds all the way like that. It's not a straight line, so it's not that accurate. A more accurate way would be maybe taking a piece of string and putting the string and measuring up to the line, right? And then going and compressing it so it's measuring up and it follows the line, and then stretching it out and measuring how long the string is. That would probably be your most accurate way of doing it. Okay? All right, let's take a look at our next question. So here we go. It says, Tyler's scale diagram of a tower shown in the is shown. Okay, the actual tower is 240 meters tall. Okay, write a scale that Tyler used. So the actual tower is 240 meters tall. So let's measure how tall this tower is. Okay, so I measure from here to here. I get this from the top to bottom. This is actually from here all the way down is 8 centimeters. Okay, so what is the statement? Well, he has the new, so we have 240 to 8. Okay? Or sorry, new is 8. Sorry, we always do new first. We have 8 to 240. Or we could also say 8 over 240. Okay? So then, if we break this down, divide both by 8, 1 centimeter is equal to, that divided by 8 is going to be equal to 30 meters. Okay? Now, let's write this as a rate. Well, that is 1 to 30 meters. Let's write this as a ratio. So as a ratio, we need to be in the same units, if you remember that. So we have 1 centimeter is equal to, well, 30 meters multiplied by, how many centimeters are in a meter? 100. Okay? So that gives me 1 centimeter is the same as, there we go. Oops, and I don't now need my units. Sorry, we don't need the units. So 1 centimeter is equal to 3,000. Oops, I have 1 too many zeros. There we go. It should be 3 zeros. Okay? Is equal to 3,000. Now, let's take a look at the next one. It says, Kylie, okay, from Abstract Renovations Designs, designs a plan for a candy store to be renovated. The scale drawing on the plan of the candy store is 1 centimeter is equal to 50 centimeters. So really, that is a ratio, 1 to 50. Okay? What are the actual dimensions of the storage room if the scale diagram dimensions are 8 centimeters by 12 centimeters? Well, if I look at this, we have 1 centimeter to 50 centimeters. So I'm going to say we have 8 over x is equal to 1 over 50. Okay? So I want to solve for x here. So we're going to first look at my 8 centimeters. That is going to be x is equal to, I put that there, 8 over, multiply by 50, right? So we cross multiply. It's going to be equal to 8 multiplied by 50 and divided by 1. So we end up getting 8 multiplied by 50 is 400 centimeters. So that's that one. Now let's take a look at the next one. And we're going to call this my y. Okay? So just so we know the two other ones. So my y dimension. So this is base, x, and y. Okay? Because we look at this, we have x, we have y. So we know y is equal to 50. And if we're looking at this, I know 12 is equal to 1. So we want to figure out 12 is equal to 1, because this is my 1, and we want to figure out my big, right? So my new. Okay, so there's my scale. So I re-multiply, cross-multiply everything, and I end up getting 50 multiplied by 12 is equal to y, which gives me 600 centimeters. So my actual scale is 6 meters by, or 4 meters by 6 meters is my actual scale. Okay? So, now it says, what are the dimensions of the plan if the dimensions of the chocolate section store expanded to be 3.5 meters by 4.7 meters? Okay? So for this one here, we have to figure out what's happening. So I'm going to do the same thing again. We have 1 to 50. Oops. Okay, what are the actual dimensions on the plan if the dimensions of the chocolate section stand to be 3.5 by 4.5? Okay. So we have, once again, it's 1 to 50, right? And I know this is 3.5 meters, which is 350. And I'm going to have x on the plan. So we're working in reverse. This is referring to the new. And I put that into centimeters. So we're in the same ratio. Okay? So I end up going, and I'm going to flip this. So I have 350 divided by 50 is equal to x. So I get 7 is equal to x. So I have 7 centimeters. Now let's take a look at my y. Same idea. We have 1 to 50. Okay? So I look at that. That's 1 over x. And we have 475. Okay? So 475 is my big scale. I want to continue this. I end up getting 1. I get x is equal to, we just cross multiply, rearrange for x, 475 divided by 50. Okay? So 475 divided by 50 is going to give me a total of 9.5 centimeters. Or sorry, 9.5 centimeters. Okay? So we have my two scales. Because this is in centimeters, and that's going to be centimeters. Centimeters, everything's in centimeters. Okay? So there is my scales. 9.5. So it's really going to be 7 by 9.5 in the scale diagram for that extension. So that is everything. Hopefully you understood this. As I see you tomorrow, if you have any questions or clarities, I showed you kind of two ways. I prefer to go the first way we did, like that there, but I showed you two ways of how to solve this. Hopefully you understood. Good luck as I see you tomorrow and we work on this together.